Good morning student, welcome my channel Bhuloks Mathematics. Last class I have already discussed about the application of Leibniz theorem. Using Leibniz theorem, we have already worked out some important problems which is very useful for those students who is studying +3 science as well as a minor elective and mathematics honors students. Let us come and discussing about some problems related to Leibniz theorem. Okay, so question is y to the power 1 by m plus y to the power minus 1 by m is equal to 2x. Then prove that x square minus 1 yn plus 2 plus 2n plus 1 whole into x yn plus 1 plus n square minus n square whole into yn is equal to 0. This is the application of Leibniz theorem. Okay, how can you do it? Come and discuss now. Okay, now answer, write down y to the power 1 by m plus y to the power minus 1 by m is equal to 2x. Okay, y to the power 1 by m plus y to the power minus 1 by m is equal to 2x. Let, write down, let y to the power 1 by m is equal to p. I am taking this is a p. When it is p, then this can be written as p plus p to the power minus 1 is equal to 2x. So here it is p plus 1 by p is equal to 2x. So now taking the LCM, p square plus 1 is equal to 2x into p. Multiply. So here it is p square minus 2x into p plus 1 is equal to 0. So this is a quadratic in p. Write down. This is quadratic in p. So applying the Siddharacharya formula, p is equal to minus b means it is 2x plus minus b square. B square means it is 4x square minus 4ac. A is 1, c is also 1. 4 into 1 divided by 2 into 1. So we have to write 2x plus minus 4 taking common, whose root over is 2. Here it is x square minus 1 divided by 2. Now 2 is taking common from whole. So we get 2 whole into x plus minus x square minus 1 divided by 2. So 2 to cancel. So there are two roots. One is x plus x square minus 1 root over. Another is x minus x square minus 1 root over. So let us take p is equal to, first of all I am taking p is equal to x plus x square minus 1. So p is nothing but y to the power 1 by m. Write down. P is equal to y to the power, write down, y to the power 1 by m is equal to x plus s square minus 1. I am taking the positive sign first. Then we have to take negative sign. This is also true. Okay. So y to the power 1 by m is equal to this. So y is equal to x plus root over of x square minus 1 to the power m. Okay. So now the function is set. Y is equal to x plus x square minus 1 to the power m. Now differentiating on both sides with respect to x. Differentiating, write down, differentiating on both sides with respect to x. Okay, so dy by dx, write down, dy by dx. So d dx of x plus s square minus 1 to the power m. Here it is a box to the power m. You know that d dx of fx to the power n derivative na fx to the power n minus 1 derivative of fx. Applying the chain rule. Here in place of fx is x plus x square minus 1 whole to the power m. fx to the power m. So derivative ma, fx means x plus root over of s square minus 1 to the power m minus 1 into derivative of x plus root over of x square minus 1. Okay, so now we get, here it is ma whole into x plus s square minus 1. Now derivative of sum is equal to sum of their derivative, applying derivative of x is 1. So here derivative d dx of s square minus 1 to the power half 1 by 2 root over of s square minus 1 into derivative of s square minus 1, that is 2x, applying the chain rule. Okay, now we have to take the LCM. It is m minus 1. Okay, so now ma whole into x plus root over of s square minus 1. Here it is taking LCM m minus 1. Here it is m minus 1. Here it is s square minus 1 plus x divided by root over of s square minus 1. So here it is base equal, power will be added. Here it is m minus 1, here it is 1. Base equal, power will be added. So we get, here it is ma, here we write x plus s square minus 1 to the power m divided by root over of s square minus 1. So now in place of x plus s square minus 1 root over whole to the power m is nothing but y. So in place of these we have to put y. So write down, in place of this we have to put y. So we write now we get, here we get dy by dx is nothing but it is y1. Here it is y1 is equal to ma into y root over of s square minus 1. Okay, now multiply y1 into root over of s square minus 1 is equal to my. Now squaring on both sides. Write down, squaring on both sides. Squaring on both sides. Here it is s square minus 1. y1 square is equal to m square y square. Okay. Now differentiating on both sides with respect to x. d dx of s square minus 1 y1 square into m square is a constant that is coming outside, d dx of y square. Now here we have to apply the product formula. It is u, it is v. U derivative of v plus v derivative of u. Now applying the product formula. S square minus 1 into d dx of y1 square plus y1 square into d dx of x square minus 1. Here it is m square. d dx of y square is 2y into y1. Okay, 2y into y1. Y to the power 2. 2 into y, derivative of y, that is y1. So y1 square derivative, write down, it is s square minus 1 y1 square derivative 2y1 into y2 ddx of y1, that is y2. Now ddx of s square, it is 2x. Here it is m square 2y into y1. Now we have to take 2y1 common. 2y1 taking common, we get 2y1 taking common, we get s square minus 1. Here it is y2 plus xy1 is equal to m square 2y y1. So 2y1 cancelled. 2y1 cancelled from both sides. So we get now s square minus 1. Here it is y2 plus xy1 is equal to m square y. It is the, okay, x square minus 1 whole into y2 plus xy1 is equal to m square y. Now we have to apply the Leibniz rule. Now write down applying the Leibniz formula, Leibniz theorem. Write down applying Leibniz theorem for higher order derivative. Applying. Write down applying Leibniz theorem for higher order derivative. So d to the power n dx to the power n of s square minus 1 into y2 plus d to the power n dx to the power n of xy1 is equal to m square d to the power n dx to the power n of y. Okay, so now applying Leibniz theorem. Here it is u, here it is v. Write down apply nc0 d to the power n dx to the power n of y2 into v. V means s square minus 1 plus nc1 d to the power n minus 1 dx to the power n minus 1 of y2 into v1. v1 means derivative of this. It is 2x. Now plus nc2 d to the power n minus 2 dx to the power n minus 2 of y2 into derivative of 2x, that is 2. Now this Leibniz theorem will come to help here because next step the derivative of 2 will become 0. Now applying the Leibniz theorem also here. Write down nc0 d to the power n dx to the power n of y1 into v x plus nc1 d to the power n minus 1 dx to the power n minus 1 of y1 into derivative of x, it is 1, is equal to m square d to the power n dx to the power n of y, that is yn. Okay, now nc0 is 1, d to the power n dx to the power n of y2, that is yn plus 2. So write down last step s square minus 1. Here it is yn plus 2. So nc1 is n. Remember nc1 is n. n minus 1, here it is 2. So power adding n minus 1 plus 2, it is yn plus 1. Here it is 2x plus nc2 n into n minus 1 by 2. n into n minus 1 by 2. Here it is n minus 2 of y2. That is, it is yn. Here it is also 2. Now plus nc0 again 1. d to the power n dx to the power n of y1. It is yn plus 1 into x. nc1, it is n. d to the power n minus 1 of dx to the power n minus 1. It is yn. Next it is minus n square yn is equal to 0. Okay. So now here it is yn plus 1. Here it is also yn plus 1. Here it is yn. Here it is yn. Here it is also yn. These two cancel. So now simplifying common. So we get s square minus 1. Here it is yn plus 2. Yn plus 1 taking common. X is also taking common. X yn plus 1 taking common. We get here it is 2n plus 1. Here it is 2n plus 1. Now yn is taking common here. We get yn taking common. We get n into n. It is n square minus n. Here it is plus n minus m square is equal to 0. Here plus n minus n cancel. Okay. So the answer will be reached here. Write down. Proved. S square minus 1. Here it is yn plus 2 plus x yn plus 1. Here it is 2n plus 1. Here it is yn n square minus m square is equal to 0. So proved. Very important question. As far as your examination is concerned, it is a very long question. Okay, so the answer will be reached. Now we have to discussing another question. Write out. Suppose y is equal to, write down one question. Y is equal to x square e to the power 3x. Find yn. Find yn. Okay. Here y is the product of two functions. In order to find out the nth derivative of product of two functions, we have to apply the Leibnitz theorem. So here we choose u is equal to e to the power 3x, v is equal to x square. Okay. So what is un? Un is equal to 3 to the power n into e to the power 3x. What is un minus 1? Here it is n, here it is also n. n minus 1 means it is 3 and minus 1 into e to the power 3x. Okay, un minus 2 means here it is 3 to the power n minus 2 into e to the power 3x. Again, v1 means derivative of x square, it is 2x. v2 means it is 2. v3 means it is 0. Okay, v3 becomes 0. Now applying the Leibniz theorem. d to the power n yn, d to the power n dx to the power n of s square into e to the power 3x. What is the Leibniz theorem? Write down nc0 un into v, nc1 un minus 1 into v1 plus dot 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 ncn u into vn. This is the Leibniz theorem. Okay, now applying nc0 un. What is un? 3 to the power n into e to the power 3x into v means it is x square plus nc1 it is n. un minus 1 I've already found here, 3 to the power n minus 1 into v1 means derivative of x square, it is 2x plus here it is next nc2 means n into n minus 1 by 2. Next step nc2 un minus 2 means 3 to the power n minus 2 into derivative of 2x in 2. So Now the process will come to halt here. Okay? Now the process will be come to halt here. Okay? Thank you to all for watching my videos. Please subscribe my channel, like my channel and share my channel.